Have you ever wondered what's really going on inside your phone or your computer? Well, today, we're going to pull back the curtain. We're going to look at the fundamental recipes that make it all work. And those recipes are called algorithms.
So let me ask you a question, and it might sound a little weird at first. What does a recipe for a chocolate cake and your favorite app have in common? The answer to this actually gets right to the heart of how computers think.
And there it is. They both rely on a precise set of instructions to get something done. That's all an algorithm is. It's not some kind of magic. It's just a logical, step-by-step guide. Just like a recipe tells you exactly what ingredients to mix to get a cake, an algorithm tells a computer exactly what to do to get a result.
Now, there are a ton of different algorithms out there, but you know what? Most of them, when you get right down to it, boil down to two really fundamental jobs. First, putting things in order, and second, finding what you're looking for. We're talking about sorting and searching, and we're going to break them both down.
So let's dive into sorting first. Think about it. So much of what we do on our devices is all about putting things in order, right? You're alphabetizing your contacts, you're organizing your emails by date, you're listing products on a shopping site by price. That's all sorting.
But here's the thing. There isn't just one recipe for sorting. It's not a one-size-fits-all deal. Here are three classic methods you see here: bubble sort, quick sort, and insertion sort. Each one has its own unique strategy, and each one is better for different kinds of jobs. Let's see how they actually work. All right, first up, bubble sort. This one is probably the simplest to understand. Imagine you have a jumbled list of numbers. Bubble sort just plods along, comparing two numbers right next to each other. If they're in the wrong order, it swaps them. Then it moves to the next pair and does it again. It just keeps doing this over and over, and with every full pass, the next biggest number kind of bubbles up to its correct spot at the end. It's methodical, for sure, but as you can probably guess, it's not exactly the fastest kid on the block.
So if bubble sort is slow, how do you sort things, well, quick? That's where quick sort comes in, with its brilliant divide and conquer strategy. It cleverly picks one item from the list and calls it the pivot. Then, super fast, it shuffles everything smaller than the pivot to one side and everything larger to the other. Then it just does that same process on those two smaller groups, and it keeps dividing the problem until, boom, the entire massive messy list is sorted with incredible speed.
And then there's insertion sort. I promise you've probably done this without even realizing it. Just think about picking up a hand of playing cards. What do? You take one card at a time and you slide it into its correct spot among the cards you're already holding. That's it. That's insertion sort. It's really intuitive, and it's super efficient for smaller lists, or lists that are already pretty close to being in order.
Okay, so we've got everything sorted and organized. Let's move on to our second main category, searching. Now that all your data is in nice, neat rows, how do you actually find that one specific thing you're looking for? The needle in the digital haystack. That's the whole challenge of searching.
Well, the most basic way to search for something is called a linear search. To picture this, imagine I gave you a giant phone book, but it wasn't alphabetized. It's just a random list of names. How would you find your friend? You have no choice, right? You'd have to start at page 1 and check every single name, one by one, until you found it. It's simple, and yeah, it'll always work, but man, if that list is huge, it can be painfully slow. But what if that list is sorted? Well, now we're talking. That changes everything. Now you can use a much smarter, faster method called a binary search. Instead of starting at the beginning, you jump straight to the middle of the list. You look at that item and you ask, is the thing I'm looking for higher or lower? If it's lower, you can instantly throw away the entire second half of the list. You don't even have to look at it. Then you just do it again with the half that's left. You chop the problem in half again and again and again. It is incredibly fast.
And this is the crucial point. This is the big aha moment. The amazing, mind-blowing efficiency of a binary search is only possible if the data has already been sorted. This is where it all clicks together. Sorting makes powerful searching possible.
Okay, so we've got our recipes for sorting and searching. But where does the data itself actually live while the computer is working on it? That's where something called data structures come in. And we're going to look at two of the most basic and important ones, stacks and queues.
So, what's the difference between them? Honestly, it all comes down to two simple little acronyms, LIFO and FIFO. LIFO means last in, first out, and that's how a stack works. FIFO means first in, first out, and that describes a queue. Let's make this crystal clear with a couple of really simple analogies.
A stack works just like a stack of plates at a restaurant buffet.
You put a new, clean plate right on top of the stack. And when the next person comes along, where do they take a plate from? The top. So the very last plate you put in is the very first one that gets taken out. Last in, first out. Simple as that.
A queue, on the other hand, is even easier. It's a queue, like a line. Think about waiting for a bus. The first person who shows up and gets in line is the first person who gets on the bus when it arrives. The first thing that went in is the first thing that comes out. First in, first out. It's fair, it's orderly, it makes perfect sense.
So okay, we've talked sorting, searching, stacks, and queues. Why does any of this stuff really matter? Because these simple, logical recipes aren't just abstract ideas, they are the absolute, fundamental building blocks of the digital world we live in every single day. Seriously, every time you search for something on the web, sort a column in a spreadsheet, or even hit the undo button in a document, which, by the way, often uses a stack to keep track of your changes, you are seeing these algorithms in action. They're the invisible engines running behind the scenes, turning digital chaos into perfect order.
So you see, this isn't just some abstract computer science lesson. By understanding these ideas, you're actually learning the language of problem solving that powers our entire world. So the only real question left is, now that you know the basic recipes, what are you going to build?